For the ready portion of lesson 2.4, we are looking at the intercepts, the Y-intercepts, and seeing how they can help us understand the equation that you see down below. Now, each of these equations down below are written what we call standard form. So looking at the equations and the graphs, I need to try to match them up. And it's going to be hard because I'm only going to do the odds, but we can see some key points. So for number 1, and for all of them, the first thing that you'll want to do is identify that y-intercept. So we want to see where it crosses the y-axis, and for number 1, we would just go down 1, 2, 3, 4, 5 units. So since we're going down 5 units, our y-intercept would be 0, -5. So that's the first part, is to state the y-intercept. The second part is to match that graph. Now, because I know that it's going down 5, our x value is 0, our output, our y value would be -5. So we need to look at all of these equations and figure out when I plug in 0 for x, which one gives me -5 for y. We could do this the hard way. We could plug in 0 each time. Or what we can do is we can say that I know that, for example, I know that C is the correct answer for number 1 because if I plug in 0 for x squared and 0 for 3 times 0, I get 0. Okay, 0 times 0 is 0. 3 times 0 is 0. The only thing remaining is that C value. It's the -5. And the C value as in, when we're doing this, ax squared plus bx plus c. Okay, so this is our standard form. We need to look for that c value, and that's going to tell us our y-intercept. So for number 1, we should say that it is f of x equals x squared plus 3x minus 5. For number 3, we're going to go through the same exact process. Go up 1, 2, 3, 4, 5. So we know that our y-intercept is at 0, 5. So positive 5 this time, which tells me that I need to look down at the equations and see which one ends in a 5. Sure enough, it is equation B. So f of x equals -0.25 x squared minus 2x plus 5. Now there are other indicators that we can use to identify that this is the correct graph. We know that we have a negative a value, and that a value is between 0 and -1. So we know that it's going to be wider than what our parent graph is. Since it's negative, we know that it's going to be pointing down. So we can use those indicators to confirm, yes, in fact, this is the correct graph. For number 5, again, identify that y-intercept. This time it's at 0, -1. So I need to look and see which one has a c value of -1, and it is equation A. So we would have f of x equals -x squared plus 2x minus 1. It looks very similar to a parent graph, which is good. That means that it doesn't have a decimal value or fraction value for the a. It also doesn't have an a greater than 1. We do know that it's negative, so it should be pointing down, which it is, so that's good. So these are just little things that we can do to confirm our answer. So that is for the ready portion. For the set portion, it's a lot of what we talked about in the lesson itself. So we want to find the missing constants. We want to find that c value. The first thing that I'll do before I find the c value is I'm going to see what I can factor out. Okay, when we're building area models, we want to only have to build one of those models. So I want to see what does 1 look like, and then I can just duplicate it however many times I need it. So for number 7, 8 and 9 actually, but for number 7, we know that we can pull a 5 out of both of these terms. So if I do that, it would be 5 times x squared plus 30x, oh, not 30, getting ahead of myself, 6x plus something. And now that something is what we talked about during the lesson. In order to find our c value of a perfect square, we'll take the b value, divide it by 2, and square it. So 6 divided by 2 squared. 3 squared gives me 9. So now because of that, we have this 5 on the outside. We need to figure out what this value is. Well, 5 times 9 is 45. The last part here is it's asking us to determine the dimensions of the squares in each problem. So the dimensions of the squares, okay, remember, 5 perfect squares. So what are the dimensions of this area? We need to think about what two terms can multiply to get on the inside. So we know that the dimensions are going to be x plus 3 squared. So the dimensions are right here, x plus 3 times x plus 3. We'll do another one. For number 9, same process. Pull out the a value, so factor out the a value. And then take half of b and square it. Well, in this case, b is 2. So 2 over 2 is 1. 1 squared is 1. And if you multiply that 5 in, distribute that in, you would get 5. The dimensions of each square would be x plus 1 times x plus 1.
Hey, jackass.
As a little bonus, I'll do number 10, just because I want you to see what's happening here. We need to write 2 equivalent equations. The first that I'd like to do is just clean up the muck. Just take care of what I see and call it good. And what I see is 2x squareds. I see 4 x's. And I see 1, 2, 3, 4, 5 single squares. So that would be one way of doing this. Another way would be to try to build the perfect squares that you see. And the hard part with that is that they have to be perfect. So I'm going to split each of these in half. And actually not each of them, as you'll see what I've got going on here. And I'm going to give this to square 1 and this to square 2, this to square 1, this to square 2, and this is going to be a leftover. You're going to see what's happening here. So we'll call this square 1 and this square 2. Square 1 gets that. Square 2 gets that. Square 1 is going to get, oh, it's going to fill up. Let me draw one down below. And square 2, it's going to fill up. So then it doesn't fit into the square anymore. I got to fill it one below. And then there's one more extra. So here's what we have. We have x squared plus 2x plus 1. And I've got 2 of those groups, but then I've got 3 left over on the outside. Here's your x squared, here's your x, and your 1. I've got 2 of those groups, but then I've got these 3 blocks left over. Or you can set this up a third way. I know in the problem it's asking for 2 equivalent equations, but you can also talk about the dimensions, x plus 1, and x plus 1. So you could say that it's x plus 1 squared plus the 3 leftovers, and we have 2 groups. For number 11, it's building off of, again, the stuff that we talked about in the lesson 2.4 itself, but I understand it might be a little bit challenging. So we need to determine if it is a perfect square or not. So if it's a perfect square, I can take this b term, cut it in half, square it, and get the c term. But I'm seeing right away that 10 divided by 2 squared is not 14, it's 25. So if it's not a perfect square, I need to find the perfect square that seems the closest and show how it can be adjusted. So instead, I'm going to say that the perfect square that's the closest, a of x equals x squared plus 10x plus 25. I want this as my perfect square. But if I want that, I still have to end up with 14. So I need to think about a number that I can subtract from 25 and still get 14. That would be 11. So we can take this perfect square here, build whatever we want to build, and then just subtract 11 at the end. We would still end up getting our solution. The next one, for number 13, same process. First thing I'll do, though, is I'm going to factor out the 3. So if I divide everything by 3, I would get that. And I need to take my b over 2 squared. So that would be 6 over 2, which is 3, and square it. So it would be x squared plus 6x plus 9. And then I need to square it. Or sorry, I've already squared it, but I had minus 4. Okay. So we're trying to, in this spot here, we're trying to make sure that we still maintain that it actually equals minus 4. Okay. So what we can do here is we can say that 3 times x plus 3 squared minus 13. It's going to take some practice to get used to this, but we'll get there. If you wanted to simplify this out, which I encourage, you would say 3 times x plus 3 squared and then distribute the other 3 in. or distribute the 3 into the other term. So 3 times x plus 3 all squared minus 39. For number 15 and 17, it's kind of a breath of fresh air because what we're doing here is we're plugging that, or substituting that 5 in everywhere we see an x. So a little bit of that review. So f of 5 equals 4 times 5 squared minus 3 times 5 minus 25. 5 squared is 25. 25 times 4 is 100. 3 times 5 is 15. So when it simplifies out, f of 5 is going to equal 60. Similar process for number 17. Number 17 is, the only difference though is that it's into the g function. So g of negative 5 equals negative 2 times negative 5 squared plus negative 5 minus 5. So multiplying this all out, negative 2 times 25 minus 5 minus 5, negative 50 minus 5 minus 5, g of negative 5 should get you negative 60. Hopefully this helps. Reach out if you have any questions.